Nazi, for the introduction. As said, we are going to change a little bit the scope of the presentation. Just let me introduce the Sphere project. This was actually the first H2020 project to mention the digital twin concept aimed at the built environment. And by this, what I want to say is that this project started 1st of November 2018. It just ended a few months ago. And that means the proposal was written 5 years ago. That's a huge time in terms of digital twins, at least in the built environment. So by this, what I want to say is that the original concept was to build a beam-based platform to improve the energy efficiency and sustainability of buildings in the entire life cycle. So from design stage to operation and maintenance. Also with this, what I want to say is the first idea was to build an ad hoc platform. And we eventually came up with this conclusion that it made no sense to build just a platform, but the concept that I think it was mentioned before by Juan, a platform of platforms, or what we called in Sphere project, a digital twin environment. And what we meant in Sphere project was we had 3 core services or 3 core platforms. I'm trying to be quick because of the time and so on, but the Sphere consortium is here represented by IDP, BTT, and NEANX at the very least, and of course, BDTA. These 3 organizations were putting on the table, providing these 3 core services or platforms. In addition to that, we had 16 different tools or microservices, services, whatever you want to call them, linked with these 3 core services and based on Beam models and Beam data through web API services. We had also 4 use cases, 4 demo sites, which you can see here. All of them buildings, 2 of them new construction projects, and the 2 other ones just refurbishment. So the idea was also to aim at 2 different kind of projects. Just here an overview of the architecture and the 4 demo sites I've mentioned, the 3 core services platforms, and then the other services. Just we had a lot of services focused on design stage, and then a lot of other ones aimed at the operation and maintenance, and then just a couple of them aimed at the construction stage, so bridging from this design to the operation and maintenance phases. Just a few screenshots of what we've done. I'll later on show a video of Sphere project, just summarizing and explaining in further detail everything I'm showing now, but just this is kind of the landing page with the 4 different projects. And once in there, like you cannot see here, but you had the possibility to access whatever core services you wanted, IDPs, BTTs, or NEANX. These are a few screenshots of IDP's digital twin, where you can see kind of the building and all the information critical IFC, and like on the left side, you can see the services or microservices linked to this specific building. Yeah, a few more screenshots. This is just for the prevention and maintenance plans. This, for example, is showcasing real-time data and historic time series of data gathered from the building and linked to specific assets or equipment or spaces, rooms, whatever. Here is an LCC, a concrete management tool and life cycle cost and life cycle analysis tool linked with the concrete elements of the building, so you can analyze the impact of the impact of the concrete that you chose in comparison with other standard concretes. We had here a master builder solution for Mabas. So we had this database comparing some specific concrete choice against other ones. Here are tools by EcoSimpro and iPredict by EuroCAD, showing the impact of choosing certain assets, certain equipment against other more standardized, let's say. Here a few screenshots also from the other core service from Neonex, kind of ontologies and semantics beam-based management. And finally, a few screenshots also from BTT's research portal, which basically collected a huge amount of sensor data and allowed users to check it, analyze it, visualize it, etc. So as promised,
welcome to video introducing.
We will have here Yannis' lovely voice to present everything. Sorry, Yannis, but
project.
Anyway.
The aim of project has been to develop lifecycle value through building digital twins. We call this peer ecosystem. First, the user enters to a landing page. The monitoring data and building assets are available in 3 core services. Project partners have developed 16 tools to provide added value for the end users. For example, on energy, simulation, indoor conditions, and costs. 4 pilots are interesting combination of new construction and renovation. An iconic office building from hybrid elements is at Luxembourg, an energy positive row house in the Netherlands. In Italy, apartment building got a new floor on top, and energy renovation was done to a factory building in Finland. The monitoring data from Luxembourg and Italy pilots is collected to IDBD twin. First, there is storage with BIM models. Monitoring data is read from the building automation system, and locations are marked. Modeling data is also in Neonex portal. The building is made from hybrid elements from concrete, metal, and timber units. In Italy, the monitoring data comes through Motus. Assets are listed in inventory. It's possible to add documents, plans, and issues. For predictive maintenance, work orders can be added and managed through a calendar. For monitoring, the current values are listed next to the item. Values for a longer period of time are in dashboard. CMP tool is for lifecycle analysis in concrete structures. Lifecycle costs are addressed with LCCCA tool. To simulate energy, EcoSim Pro provides results for different flows. Abnormal situations in predictive maintenance are detected with iPredict and IMAN tools. Communication with that authoring tools is the strength of Neonex portal. It is capable to keep track and exchange various attributes. There is also an integration to Blink2Go for defects. Monitoring data from the Netherlands and Finland pilots is stored to VTT research platform. For both pilots, there is already over 1 year of data available. For the Netherlands, the dashboard has drop-down menu for dwellings. The first year showed already that the house is energy positive with panels. ENMS tool is designed for setting projects energy management. For the RobMOS tool, it's possible to predict, for example, heating and cooling. Current values for simulations are exported to Neonex portal. For the time series values, there is dashboard in VTT research platform. Finland pilot has already shown 30% reduction in energy consumption. New building automation system with smart sensors adjust heating to conditions in the factory. The savings are significant. Annually, we talk about many thousand megawatt hours. Providing good indoor conditions for employees is also important. Human thermal model provides means to simulate how different employees, men and women, are experiencing thermal conditions. These results are outcome of 4-year collaboration. The consortium wants to thank you for watching.
So, yeah, thank you. Just as a last comment, it wasn't a goal of the project at the beginning of it, but an outcome of the Sphere project was the BDTA. And that was kind of an outstanding, let's say, outcome just to create this organization out of a European project and highly highly evaluated by the European Commission. And then thanks to this VDTA, we can be here presenting Sphere project and other projects and having this really interesting meeting. So thanks.